Hey, what's going on, everybody? Mr. Crawford here. Today I'm going to be discussing Integrated Math 2, Practice 5, Square Roots and Cube Roots. Do you guys know some perfect squares? If you were to take each one of these numbers and raise it to the second power, which means making it multiply itself, do you know what you would get? Do you know what 0 to the second power is? Or 0 times 0? Yeah, it's just the number 0. How about 1 times 1? 1. 2 to the second power would be 2 times 2, which is 4. 3 to the second power would be 3 times 3, which is 9. 4 to the second power is 4 times 4, which is 16. 5 to the second power is 25. 6 to the power of 2 is 36. 7 to the power of 2 is 49. 8 to the power of 2 is 64. 9 to the power of 2 is 81. How about your perfect cubes? What if you took each one of these same numbers but raised it to the third power, made it multiply itself 3 times, right? Like, what is 7 to the third power? Well, that really means 7 times 7 times 7, which actually makes the number 343, right? Can you do the rest? What is 0 to the third? 0. 1 to the third? 1. 2 to the power of 3 is 8. 3 to the power of 3 is 27. 4 to the power of 3 is 64. 5 to the power of 3 is 125. 6 to the power of 3 is 216. We did 7. 8 to the power of 3 is 512. And 9 to the power of 3 is 729. Come down here and see if you can answer the following. If that's true, do you know what the square root, or the opposite of the power of 2, of 25 is? Well, if 5 to the second power is 25, then the square root of 25 is 5. Square root of 81 is 9. Square root of 0 is 0. Square root of 1 is 1. Square root of 36 is 6. Square root of 9 is 3. Cube roots. These guys are the opposite of the power of 3. Notice that if they don't write a power here, or a root here, excuse me, that obviously understands that it's 2. Anything else, and they got to actually put a number. So now we're looking for the cube root of 8. And if I go back to this list, 2 to the third power is 8. So going backwards, the cube root of 8 is 2. The cube root of 0 is 0. Cube root of 64 is 4. Cube root of 729 is 9. Cube root of 343 is 7. And the cube root of 1 is 1. But most square roots and cube roots and roots in general are not perfect, right? There's a lot more numbers that aren't on this list than are. So what do we do when we need to simplify a non-perfect root? For example, the square root of 20, if we were to get a decimal version, is about 4 point something another, right? There's blah, 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 blah out here. But we don't want the decimal version. We want the simplified radical version of the square root of 20. And the way you do that is you create factor trees. If I'm breaking down the square root of 20 and trying to think of two numbers that multiply to make 20, I think of 2 times 10 right away. You might have thought of 4 times 5, and that's fine. As long as we continue, we'll both end up in the same place. 10 can be broken down into 2 times 5. Once you break a number down, it's not there anymore. So if you'll notice, I ended up with a 2, and a 5. None of these numbers can be broken down anymore because they're already prime numbers. 2 times 2 times 5. If we were to multiply them all, would get us right back to 20. 2 times 2 is 4. 4 times 5 is 20. But the reason we broke it all down like this and did its prime factorization is because we're looking for something specific. Underneath a square root sign, or the power of 2, right, the second root, or the square root, we're looking for groups of 2. Any number that shows up 2 times gets to circle up and come out to the front of the radical sign. So now we have 2 in front of a radical sign, and what's left over is anybody who didn't have a pair, which in this case was 5. So the square root of 20, simplified, is 2 times the square root of 5. If you type this into a calculator, you're going to get the exact same decimal number, 4 point whatever, as you will the square root of 20. So 2 square root of 5.
Pardon the interruption. Can somebody from the ABM crew meet Mr. Kilkenny in the main office? Can one of our custodial staff members meet Mr. Kilkenny in the main office? Thank you.
Yeah, I guess you can tell I'm still at the building. It is Academy Showcase night, so hopefully you'll be coming up. We'll see. All right, square root of 28 then. If I wanted to simplify this root, I'm going to break it down, and the first numbers I think of are 2 times 14. 14 can be broken down into 2 times 7. And then I'm done breaking it down because neither this 2, nor this 7 can be broken down with anything other than 1 in itself. That's what makes them prime numbers. So I'm left with 2, 2, and 7. Since I'm under a square root, I'm looking for a group of 2 or a pair. Whoever can pair up gets to come out from under the square root sign to the front. And I end up with 2 in the front times the square root of anybody who didn't come out, which was 7 in this case. So the square root of 28 simplified is 2 times the square root of 7. If I do the square root of 180, I think of 2 times 90. 90 is 2 times 45. And if the times tables are a struggle for you, I'd recommend just getting a calculator and hitting divided by 2 or divided by 3 until you get something that works, right? 45 could be 3 times 15, and 15 could be 3 times 5. Gone, 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 and gone. What I end up with is a 2, a 2, a 3, a 3, and a 5. You know what we would get if we multiplied all these numbers together? We'd end right back up at 180. But the reason we broke it down is because we're looking for pairs. There's a pair of 2s, there's a pair of 3s, as well as a leftover 5. So a 2 gets to come out, and the 3 gets to come out. And if more than one thing comes to the outside, they are going to multiply. 2 times 3 makes 6. Square root of what was left over? 5. So the square root of 180 simplified is 6 times the square root of 5. The process is the same when you have to do cube roots, except under a square root sign, we're looking for groups of 2, anything that shows up twice. Under a cube root sign, we're looking for groups of 3. Anything that shows up 3 times gets to come out from under that root. So 40, for example, could be 2 times 20. 20 could be 2 times 10. And 10 could be 2 times 5. Do I have a group of 3? I sure do. 3 2s. So that 2 gets to come out to the front here. It's still multiplying the cube root this time. Make sure you put that 3 in there if you're dealing with a cube root. And what was left over is a 5. 2 times the cube root of 5 would be the same thing as the cube root of 40. About the cube root of 100. 2 times 50, 2 times 25, and 5 times 5. Well, since I'm under a cube root, I'm looking for groups of 3, and I don't have it. I've got 2 2s and 2 5s. That's it. So every once in a while, we discover when we're trying to break it down that the root we were working on is already simplified. The cube root of 100 is as simple as that's going to get. So we're going to have to leave it like so. All right. Tune in for part 2 to see the backside.